Hello and welcome to day 15 of Advent of Code 2024. In today's video we have a grid system just like this. Consists of three entities. One is a wall, which is like this, the other one is a rock, and the third one is our robot. Now there are some instructions here that would move the robot around. If a robot hits a wall in its next move, it won't move there. So if the robot was here and I say go up, there is a wall here, it would stay here. If the robot hits a rock, it can move it if the rock can move. So for example, if I was here and I would say left, then this rock go here and our robot will go here. Similarly, if it was here, it would move these two rocks one step here and it would land on this spot. Now, of course, if the robot was here and I would say go to the right, it cannot move this rock into the wall, so it would stay where it is. So these are the rules for the robot. We need to do these instructions for it and see at the end of these instructions where these rocks or boxes are in the grid and then do some multiplication on those. So let's go to the code. So for part 1, again, just like always, I have some directional map, which means that if it's pointing to the top, the y should be -1. If it's to the right, do this. If it's to the bottom, do this. If it's to the left, do this. Again, just like always, reading the input, and I'm getting the parts, which is splitting by 2 new lines to get these two apart, and then I would have a grid and some instructions. The grid is basically the part 0, which is this part, and then split it by nothing. So it would be a 2D array of these values, and then instructions would be the part 1, which is be joining together. So we would have a long list of instructions. Then again I would get the width and height, and let's ignore this move box for now. Then I would first need to find the placement of my robot. So I would go to grid, and if there is a point with this sign, that is where the robot is. Okay, then for all the instructions that I have here, I would need to see what that instruction is. So if that instruction is this one, then I need to do this on the robot and possibly on the rocks or boxes that are on its way. So I would get the direction and I would create the new position of the robot based on that direction and the current position of robot. So the x would be added to the direction x, put it in the x, and similarly for the y. Now, if that position that we are talking about is not a wall, then we are fine. We can probably move there, and I said probably. If it's a wall, we won't go into this if statement and we don't do anything with the robot. Okay, but if it's not a wall, it's either an empty spot or a box. Okay, if it's an empty spot, we can safely move there. So it's like this. If I am here and I would say up, this position is a dot, so it's empty, so I can move there, fine. If it's not a dot, then obviously it's a box. Now we need to see if we can move that box or not. If we can move that box, the robot will stay at that position and the boxes shall move. So from here we can move these two, so these two will move here and this will stay will land here. Now let's go and see how the boxes move. Now in the move boxes we'll have a recursive function. For each of the position we get the next position, and if the next position is a dot, we just say okay, now this rock shall go on that place and that place should be the rock. So we swap the position of that empty spot with the rock and we say okay, we return true, So this is the case when we are, for example, here, and we want to move this to the left. When we want to move this to the left, this is empty, so this rock will land here, and this empty spot would land here, so it's fine. Next thing is that if it's a wall, we cannot move, so we return false. We say, okay, we cannot move this. Let the box be on its place. Otherwise, there is a rock after that. So we need to move that rock. So we call the move box again with the next position, which is our current position, and the direction is the same. And if that can happen, we do that and we return true for the previous one. So, for example, here. If I'm here and I say go left, I would go here, see that this is a box. From this box, I would check the next one. The next one is a box. From this box, I would check the next one. It's a dot. So I would swap these two and I would return true. Now that I return true means that this can move to here. So this will move here and this dot will move here. Okay? So this is how this recursive function works, which is the most important part of this whole logic. Okay? When the move box is done and we are going through all the instructions with these scenarios, then we need to just do the calculation as it asks us. So for all the boxes that we get, we just get the x multiplied by 100 and add 1 to it and return the value, and it's the final answer that we want to return. Okay? Now for part 2. For part 2, everything gets double. So what do I mean? If there is a single wall, it will be double wall. If it's a single box, it would be double. If it's a dot, it would be double. If it's a robot, it would be a robot with a empty space. So it would be something like this. Now this gets a little bit tricky. For example, here, if we want to move to the left, then this box and this box both move to the left. So not only one, but two of them that make a box move to the left, and they move only once. And there are some scenarios like this, that we are here but we want to move up, and this box cannot move up, so this box cannot move up because this cannot move up. When this cannot move up, however we push this, because this is blocked, this will be blocked, and because this is blocked, this is blocked. This is another scenario that we would need to consider. So again, we need to run this for some time, and at the end just get the final GPS coordinates as we defined for part 1. Now for part 2 here, we would do the same thing, just get the grid and everything. Then here, if I get to the robot, I would put it in the place. If I get to a wall, I would add 2 walls, and if I get to an O, I would just push the box to the box's position. Then for all the instructions, I would do similarly the same thing. Try to move the robot in that direction by getting the directions from the instructions, which is the same thing here. And I would perform the new position based on the instruction, adding the direction X to the robot and direction Y to the robot Y. Then I would check here. If I didn't hit a wall, then I'm fine. I would see if I'm colliding with a box or not. If I'm not colliding with a box, then I would move to that position. Otherwise, I won't move. So again, we have the move box here with the collided boxes and the direction and all the movements. And in the move box, it's a little bit different. Here, we would try to move both positions of the box. So the next is this one and this one. And if it collides with a wall, we stop all the movements, just like here. So here, we try to push this and this. Both of them hit the wall, so we stop. Otherwise, we would find all the bugs that we are collided with. Okay, so from here, when we say go up we would collide with this one. So this would be the only box that we are colliding with. But if we are here, for example here, and we say go down, we would collide with this one. Okay. If we are here and we say go left, we would collide with these two. We would find all the boxes that we are colliding with. And if we don't collide with any box, then we are fine. We can move. Otherwise, for all of those collided boxes, we would see that if we can move those boxes in that direction or not. If we could do that, basically calling this move box function again with the new position, then we are fine. Otherwise, we would say, okay, no, there is a conflict here. One of the boxes cannot be moved. And in the end, after we return from this function, we have performed a move, just like this. And after this, we just do the calculation just like before. Now this code is always available on the GitHub, so go and check that. And I hope you have enjoyed the video, and see you in the next one.